Isotropic oscillator in three-dimensional polar coordinates. Let the polar coordinates of the particle at any instant will be r, theta and phi. If the Cartesian coordinates of a particle at a instant be x, y, z, then the transformation of the equation will be x is equal to r sine theta cos of phi, y is equal to r sine theta sine phi, and z is equal to r cos theta. The kinetic energy of the particle is T is equal to half m bracket starts x dot square plus y dot square plus z dot square bracket close, which is equal to half m bracket starts r dot square plus r square plus theta dot square plus r square plus sine square theta phi dot square bracket close, and the potential energy will be V is equal to half k r square. Now Lagrangian is equal to L t minus V becomes L half m bracket starts r dot square theta dot square plus r square sine square theta phi dot square bracket close minus half k r square. So we have del L upon del R dot is equal to mr dot, and del L upon del R is equal to mr theta square plus mr sine square phi dot square minus kr, and del L upon del theta dot is equal to mr square theta, and del L upon del theta is equal to mr square sine theta cos of theta phi dot square. Del L upon del phi dot is equal to mr square sine square theta phi dot square, and del L upon del phi is equal to 0. The Lagrangian equation in polar coordinates are d over dt bracket start del L upon del R dot bracket close minus del L upon del R is equal to 0, and d over dt bracket starts del L upon del R del theta dot bracket close minus del L upon del theta is equal to 0, and the d over dt bracket starts del L upon del phi dot bracket close minus del L upon del phi is equal to 0, which is equation 1. Putting the value into 1, we get d over dt mr dot bracket close minus mr theta dot square minus mr sine square phi dot square plus kr is equal to 0, or which is equal to mr double dot minus mr theta dot square minus mr sine square phi dot square plus kr, and d over dt mr square phi dot bracket close minus mr square sine theta cos of theta phi dot square is equal to 0, and d over dt mr square sine square theta phi dot bracket close is equal to 0. Now equation 2 are the required equation of motion in the polar coordinate.